Hi, my name is Kim Shipway. I'm a product marketing engineer for Barbara Coleman Company in Rockford, Illinois. Today I'm going to talk to you about the MACO8000 and its new color operator system and how it can enhance your blow molding productivity. While I will be concentrating on the blow molding industry, these same features and benefits can be used for injection and extrusion and applied to those processes as well. Blow molding has taken on many new faces in the past few years and new features. These new features include in-mold labeling, die ovalization, auto-tune temperature control, Pearson profiling display, deviation, and process alarms. Until recently, these new features have been interfaced to the machine operator through the use of a monochrome or black and white monitor. Recently, color monitors have become into existence to interface the operator. A color monitor by itself is a little more than a cosmetic addition to your control system. That's why I would like to talk about the MACO8000 and the interactive colors and graphics. When I talk about interactive colors and graphics on the MACO8000, what I'm speaking of is colors and graphics that change based on machine operation. As the machine operation changes, so will the colors or the graphic representation. These colors can be programmed into your MACO8000 system through the use of an IBM or an IBM compatible computer. You can program up to 8 different colors into your system, and they can be programmed pixel by pixel, with the MACO8000 screen being a 320 by 200 matrix of pixels. OEMs or end users can go ahead and program their screens through the use of one of these computers for the MACO8000. What I would like to show today is a series of slides that have been taken off our actual MACO8000 screens and how they have been used to aid machine operators in their blow molding productivity. The first slide we're going to look at today is a slide showing different features that can be programmed in for the machine operators. If you'll look up on our left-hand corner of our slide, we show text sizes. There are actually 4 different text sizes that you can program in with your color operator station. Below it, we have an actual blow molding machine being graphically displayed on there. Down below that, there are bar and line graphs, the bar graphs and line graphs. Then we have individual vertical bar graphs and individual horizontal bar graphs. And up above those, we have paths for other screens. Now, if a machine operator would just go over and touch the blow molding machine over there, where it says machine status, he would pull up a screen such as this, showing a blow up of the actual machine and the barrel, where it is showing us actual temperatures versus desired temperatures. Now, in your blow molding process, or in your process, whether it be blow molding, injection, or extrusion, you can program your screens in this way. The screens could all be programmed the same for any number of machines in a plant. So say, for instance, you have 20 machines in your plant. You could set up some parameters to program them all in the same way. So let's say we set up 3 distinct colors to program your screens: green, yellow, and red. Green depicting that you're within all your parameters. Yellow meaning you're just deviating a little bit outside of spec, and red meaning you're in an alarm condition. By looking at this screen, we can see on the bar graph below that zone 1 is within specs. Zone 2 is deviating just a little bit by our yellow display on the bar graph there. And if we look up above, we can see that zone 2 actually has a set point of 350 degrees, and the actual temperature of zone 2 is 360 degrees. So you can see that we are deviating by about 10 degrees on that zone. Now, if an alarm was to occur for the machine here on the zones, we could depict those in red. And this screen could also be programmed to automatically come up as a priority alarm screen, so the machine operator would not even have to pull it up. It would automatically appear on his MACO8000. For instance, if we did have an alarm condition, the screen might appear as this, with red depicting our alarm conditions. Now if you look below at our bar graph, you can see the first bar graph for zone number 1, we have a high temperature alarm with the bar graph showing our temperature is exceeding our alarm condition. In the upper right hand corner, you can also see it's telling us our zone 1 has a high temperature alarm. Zone 2 has an HBO alarm or heater burnout alarm. The HBO alarm is telling him he needs to replace a heater band on zone 2. And it's not just telling him that, it's showing him where the heater band needs to be replaced, so the machine operator can just glance at this screen and see where he needs to replace the heater band. And so by glancing at this machine, the machine operator has the information he needs to look at the machine and correct the faulty features. The next slide we're going to look at here is a diagram of the tooling on a blow molding machine. The reason we're looking at this is more to prep for the next screen than anything else. Right now we are depicting converging tooling on this blow molding system. On a blow molding machine, you can either have converging tooling or diverging tooling, depending on what type of product you're making. The machine operator or the control system needs to know what type of tooling is in the machine. So for simplistic reasons, we can have graphic representations of the converging or diverging tooling. Say for instance our machine has converging tooling in. Then you might have a screen come up such as this one with a picture of converging tooling, with the caption above it reading, "The graphic illustration shows you are now in the converging mode of operation." By simply touching it, the tooling will change to diverging. So for instance, if we did have diverging tooling in versus converging, all the machine operator would need to do is come up, touch the picture, and we would automatically change to diverging mode of operation. Then the machine would be allowed to run. If the correct tooling is not chosen for the control system, the machine could be inhibited to run through the relay ladder diagram. This is just showing one way how a graphic representation can be used to tremendously aid a machine operator with the MACO8000. The next slide we are looking at here is a block diagram showing a MACO8000 Parison module connected up to 4 heads on our machine. Each head is working properly here, as you can see by the machine. But if we had a deviation or process alarm, this might appear differently. A deviation alarm telling us that we are deviating between our desired position and our actual position. The amount of deviation is set by a set point. So say for instance we had set in 10% for our deviation alarm and we had an alarm appear, we would know we are deviating more than 10% between our desired and our actual position for the tooling. A process alarm being a set point in percentage of tooling opening that we do not want our tooling to go below. So say for instance again, the process alarm is set in at 10%, then we know we don't want our tooling ever to close below 10%. Now let's say we had both a process alarm and a deviation alarm. Then the screen might appear as this, showing us we have a process alarm on head 2 and a deviation alarm on head 4. This can now be carried one step further. Now that we know where our alarm conditions are, a machine operator could come up and actually touch the diagram showing where our deviation alarm is, and we could pull up a screen giving the machine operator step-by-step procedures he needs to do to correct this situation. They might be checking voltages on the Parison module, checking voltages on the amplifier card, or checking the hydraulic system, and thereby, through a process elimination, correct the deviation and process alarm. The next screen we are looking at here is a profile display screen. This display screen is showing our desired position of our Parison profile. On the left-hand side of the screen there we have from 0 to 100% of tooling opening. Across the screen we have 100 points. The white markings here for set points are actual master set points. The master's excuse me, the master set points are set points between which interpolation will occur. On the MACO8000 you can have between 2 and 10 master set points. 2 master set points will give you a straight line interpolation between them. 3 or more will give you a curvilinear type interpolation. So by having as few as 2 master set points, you can generate 100 points for your profile display. No interpolation will occur before the first master set point or after the last master set point. The blue set point on the diagram is showing the actual cursor position. We can see the cursor is at the 48th position with a value of 52.40%. We also have 3 breakpoints that are available here. Breakpoints meaning areas where you're going to change color. We have green, yellow, and red. You also saw the breakpoints in the bar graphs for the machine screen depicting temperature values. This screen by itself is just showing you where you want your profile to be. It's not showing you where your tooling actually has open to or if it is following your profile. So this screen in itself is not telling you if you are really following this profile. It's telling you where you want your profile to be. So that's why we have the next MACO8000 screen, which is showing us our actual versus desired position. In the magenta color here, we have our desired position for our tooling, and the line graph overlaying over the top of it in the white color is showing our actual position. So a machine operator, by simply glancing at this, can see his actual position versus his desired position. If you will look at this a little more closely, you can see between points 42 and 58, we are deviating off of our desired position by a little bit. So we might even be pulling up a deviation alarm depending on what set point it's set at, what percentage it's set at. Now a machine operator could look at his bottle approximately at the points 42 to 58 and see if it is causing some fluctuations in his bottle. And he can see exactly where those points are now, where his fluctuations are occurring. Can carry this one step further and look at his amplifier card or his hydraulics to see why his tooling is not following his desired position. This is one of the most beneficial screens to a blow molding operator to see his actual versus desired position. We have now seen 3 specific ways in which color graphics can enhance blow molding productivity. Number 1, we looked at a machine graphic representation depicting barrel temperatures and bar graphs showing you when you had a high alarm, an HBO or heater burnout alarm, and where the heater bands need to be replaced. Next, we looked at converging and diverging graphic representations. And if your machine was not in the proper configuration for your control system, it could be changed. The control system could be changed either for converging or diverging simply by touching the graphic representation. And lastly, we looked at actual versus desired position of the Pearson profile, which would aid the operator in determining if his tooling is following his desired positions for that tooling. So now we've seen 3 ways in which the machine operator can aid his blow molding productivity, and there are many more ways depending on the creativity of the end user and the OEM to program in particular functions that will aid machine operators on their particular machines. The same type of features can be used for the injection and the extrusion processes to help improve productivity. The old adage here certainly applies. A picture is worth 1,000 words, and it applies here in improving your productivity. Thank you very much.